Okay. I don't know how much, if any of it, you need me to actually do, but because it's honestly not the first time I've done a recording for this. So if you look enough, I'm sure you could find one from another class. But at least this way, it's a little bit more personalized. I hit record, right? Okay. So pretty basic again because it's following steps. I mentioned, I think, when I did the first part of this, that it's just generally a good idea for me to do with you because if GeoGebra changed or I made a typo, this is how I'm going to find out. Because no matter how many times I do this on my own, it always works out for me, And so, if it's going to screw up, it's going to screw up in this environment. So, at least we can flesh out what the issues are. Since by putting in a coordinate, it'll define it based off of its own naming convention. So it'll call the first coordinate that I type in. It's going to call it A. I want to preempt that. I want to call it O, not 0. So O. I'm just going to do that myself. Now I'm going to try because it should default back to A after I type in the O. Let's see if that's true. Okay, I'm not lying. That's good news. Because it's the little things, when you get comfortable with GeoGebra, it's the little things that start aggravating you. Like, man, I got to type in A equals, B equals, and so on. So little things like this kind of take the sting away a little bit. Maybe not. Maybe it still sucks. I don't know. My whole goal behind all of this stuff is for you to have some visuals associated with some of the things that we're learning in class. So it can't really suck that bad. Because the alternative to this is imagine a bunch of points and you're connecting them, so at least you can kind of get a feel, even if it is kind of a pain in the ass to do, at least you're getting something, So what we want to do is create a polygon from these 3 points. Okay? Well, 3 out of the 4 points, because what we're going to do is, I thought for some reason it named it as Y, but then I realized mere moments ago, I actually named my y-axis y, and it just kind of got in the way, right? So 3 of these points are going to be living on one plane, and they're going to form one side of my rectangular prism, all right? So, or at least one facet of it, and then we're going to project up onto vector B, or point B, which would eventually become vector B, all right? So instead of actually using the polygon command, we could use the polygon tool. So you click on the shape tools here. And then, if what you're looking for is not directly visible, and it doesn't appear to be, unless I'm staring right at it, hit more, and just take a look until you find the one that we're looking for. It's the polygon one. All right, it may not have, my instructions may not have the labels that it has, because the way I have it structured on this, because I have everything kind of condensed together, it changes the naming of it. I'm sorry, I had it condensed when I did it on here I think I actually might have got these screenshots from an iPad, right? So it might be slightly different, but just look for the shape. If you get the name that goes along with it, even better, because it says we're creating a polygon, so that's your indicator. So click on that, select all the vertices. So we're going O, A, C, and then back to O in that order. So O, A, C, back to O. It snaps to fit, and you've created your polygon. All right. Now what I want to do is create a line parallel to OC through A and through AC, parallel to AC through O. All right, the idea being that we can capture the 4th vertex of one facet of this parallelepiped. All right, because what we learned 2 classes ago, well, whenever we were talking about finding the magnitude of a cross product, we learned or reviewed that half of a parallelogram is a triangle. All right, so what we created was a triangle. So if we can double up this triangle, then we'll have a parallelogram. And project that parallelogram into 3 space, you create a parallelepiped. All right. So in order to do that, we're going to select the point and then the line you want to be parallel to. So I'm going to use the parallel line tool, which is right now. All right, select the point, then the line you want to be parallel to. So the first one, we're going through A, and we want to be parallel to OC. So A and then OC, and it'll create a line parallel to OC going through A. So I'll do the same thing again. I have a tendency to be a little cautious. Sometimes, when you click on a command, it remembers that command, and then sometimes it just kind of goes haywire. So I click on the command again, and now I want to go through O. Where are you, O? Parallel to AC. All right. So then I'm going to look to find the intersection of that, because GeoGebra doesn't always assume that you want to find the intersection between, even though there's clearly an intersection there, it doesn't always assume that you want to find that intersection. So we're going to tell it to find the intersection. We could use the intersection command. All right, so you just got to find it. It's usually under lines. Where are you? No, it's angle, bisect, intersect. Okay, so points. All right. So for this one, it's pretty easy. You just select the two lines that you want to find the intersection of. So meh, and it'll do it for you. All right. So we have OCAD as the vertices of this polygon, of this parallelogram. All right. Whenever you name a parallelogram, you want to do the points in consecutive order. Right? It really doesn't matter which way you go as long as you're consecutive about it. All right. But I do want to make sure that GeoGebra understands that this is going to be a polygon. All right. So I'm going to select my polygon tool again, start with O, then CAD, and then back to O. All right, you always end where you started with. All right, so now we have a polygon going through those 4 points, and that polygon is specifically a parallelogram because we defined it that way. All right, we guarantee that opposite sides are parallel to one another, so therefore it's parallelogram by definition. All right, which is a pretty cool aspect. Now, if you imagine. Now, full disclosure, when I first did this, I did it the absolutely wrong way. I said, okay, that's one side down, just 5 sides to go. So I was like, all right, let me get to work on figuring out what the side piece would be, and then I had to map that to the other side, and then I connected, and then it made the top. It was mind bending. I enjoy that sort of thing, but it took way longer than it should have. The thing that frustrated me was that I didn't know GeoGebra was capable of just flat out doing that for you. So imagine how sheepish I felt once I discovered that. And yeah, so all it is a line command. There's an option to extrude to prism. All right, so you could try to do that. You can click extrude to prism, select the polygon, then enter the altitude. So sometimes that works. You enter to the altitude of B, enter the altitude of B, but it's expecting a number, so it's a little iffy in that regard. All right, so if you know the numerical value of B, the problem is it's ordered triple. So there's no guarantee that you're looking at something that's going to have a defined vertical height. Because the height of this, I mean, if the whole parallelogram was living in the XY plane, then its height would be a constant height. You just type it in. But this is living not on the same necessarily horizontal plane. All right, so we use the prism function, but we can't really use that tool because we can't define the altitude. You can't just put in B and have it understand what it means. All right, if it was just a single numerical value, just type it in and boom, it'll give it some height and you're good to go. All right, what some people have done in the past is they've said, okay, well, let me try 2. Does that capture B? No. Let me try 3. Let me try 2.179. All right, the better way to do it is just to type in this command, which for some reason, and this is something that I'll never really wrap my brain around, GeoGebra understands the command, the line command of what I was trying to do using its extrude to prism command. All right, so there's something about the way that it's structured that it doesn't understand it the other way.
Looking for constant versus looking for variable, this kind of stuff.
Yeah, So O, C, A, D, and then we're extruding into point B, and then it does the process just fine. And then it gives you a number like 64, and you're like, ah, gee, I wonder what that 64 represents. The answer is the volume. You know, it's giving you the length, width, and height multiplied together. You know, using the properties of parallelograms, of course, but it's giving you the volume. And so, you know, I didn't ask you to do anything specific here related to that, because I think you got, hopefully, the determinant connection after the first part of the activity, because the determinant and the area of the parallelogram in 2 dimensions corresponded, so it would make sense that the determinant and the volume would correspond. I didn't think you needed to jump through the hoops. And besides, we had an entire lesson that was based off of that. Like the triple scalar product, the determinant, we figured out volumes, and we already made that connection, so I didn't feel the need to make you just write it out just to earn a couple of extra points. All right, so that's really all you have to do. And it's a win-win for all of us, because you do that following the steps that I just gave you, and I have something very easy to grade. And it's very rubber stamp, you know, like you've demonstrated some knowledge of the technology. And really, that's all these technology assignments are about, is just you showing me that you know how to use the software. All right, so that if you come across, and maybe not even in this course, I don't know how many of you have taken Calc 3 yet, but when you're sitting in a Calc 3 class, if you have access to this information, you know how to use GeoGebra properly, then you can use that to develop your own visuals without having to be prompted by the teacher. All right, and you know, not just, you know, I mean, it's called GeoGebra for a reason, you know, so geometry course is any kind of algebra course, you know, that kind of thing. All right, so a little something.